You remember back in chapter, I want to say chapter 3, but I'm not sure. Somewhere a long time ago, we solved systems of equations. So I might have given you something like 3x plus y equals 1, 4x minus 2y equals 0. And I might have asked you to solve that system of equations. We had 3 different ways we could solve. Anybody remember any of them? Substitution was one of them. Good. Elimination. What was the third one? The third one we didn't like very much. Graphing. That's the third choice. That's absolutely correct. All right. What I want you to do is I want you to remind me, how do I solve that system by elimination? We're going to use the elimination method today. What you want to do is get one of them to equal the other, except you want one to be positive, one to be negative. Okay? So I'm going to times the first one by 2. If I times the first one by 2, that'll give me a positive 2y and a negative 2y. When I add those together, they'll cancel out. So I'm going to times the first one by 2. That's going to give me 6x plus 2y equals 1. And then I have 4x. Very good. Multiply everything by 2. Absolutely. That's going to be a 2 also. 4x minus 2y equals 0. I add those up. What do I get? 10x equals 2. So the teacher did not make up a very nice problem because we end up with a fraction or a decimal. You divide by 10, x is 1/5, which you could write as 0.2 if you wanted to. X equals 1/5. Then what do I need to do? Plug that in where? Either equation. For no particular reason, I think I'm going to use the first one. So I'm going to have 3 times 1/5 plus y equals 1. So 3/5 plus y equals 1. So y is, I subtract 3/5 on both sides. What's 1 minus 3/5? 2/5? 2/5. All right, so that's what we did back in chapter 3. We solved systems of equations. This would be called, the system we just solved, would be called 2 by 2. Why would that system be called 2 by 2? There's 2 equations and there's two variables. Excellent. Today we're going to solve 3 by 3 systems. What do I mean by 3 by 3 systems? 3 equations with 3 variables. I'll just speed one out of the book so that the answers come out nice. X plus y minus z equals negative 1. Negative 4x minus y plus 2z is negative 7. 2x minus 2y minus 5z equals 7. So there's a 3 by 3 system. 3 equations with 3 variables. Generally, these are only ever solved one way, and that's using the elimination method. The truth is, you could use substitution. It would work. But elimination tends to be a little bit more effective. A little bit quicker. So here's what you do. You pick 2 equations. Which 2 equations do you like? The first 2. And traditionally, we always eliminate the x. Does it really matter? No. You could eliminate x or y or z. The truth is, it doesn't matter. But the traditional way of doing it is we take the first 2 equations and we eliminate the x. So if I'm going to use the first 2 equations and I'm going to eliminate x, what am I going to do? Multiply the first one by 4 and then add it to the second one, and that'll make the x's go away. All right, so I take the first equation, I multiply by 4. That's 4x plus 4y minus 4z equals negative 4. And make sure you multiply everything by negative 4. For example, on the last problem, I forgot to multiply by 2 over here. That's very easy to do. That's a very easy mistake to make. Make sure you multiply by 4 all the way across. All right, then we have the negative 4x minus y plus 2z equals negative 7. And I add those together. What do I get when I add those together? Positive 3y minus 2z equals negative 11. So we picked the first two equations and we canceled out the x. Now we pick a different pair of equations. So I can use the first one and the last one, or I can use the second one and the last one, and I cancel out the x's again. So which pair do you want to pick? Do you want to use first and last, or do you want to use middle and last? First and last, okay. So if I'm going to use the first one and the last one, what do I need to do in order to cancel out the x's? Multiply the first one by negative 2. So that's going to give us a negative 2x minus 2y plus 2z equals negative 2. And then the second equation has 2x minus 2y minus 5z equals 7. I didn't do anything to that one. Add them up. And what do you get this time when you add them? Negative 4y minus 3z is 5. Negative 2 plus 7 is 5. Now look what we have. What we have now is we have this equation and that equation.
Wait, I have a question.
Go right ahead.
So you used the first equation and the last equation, and you multiplied this first one by negative 2?
Correct.
And where is it when you got it all done? Like where you multiplied it by 2?
Right here?
I'm getting like all, that's it?
Yep.
Wouldn't it be a negative 4?
Absolutely. I made a mistake, didn't I?
Okay, that's why I was confused.
Crap. Oh well, not a huge mistake. Again, I did not do that on purpose. It was an honest mistake. This happens to everybody. I was supposed to multiply by everything by negative 2. Negative 1 times negative 2 should have been positive 2. And then on the end, I heard somebody say 9 when I said that's negative 2 plus 7. Somebody said 9 and I said 5 because I made a mistake. That should be a 9.
But shouldn't it, negative 2 and negative 2, shouldn't it be a positive 4? Oh wait, that's a z. Sorry, my 2 looks like a z. Z looks like a 2. I'm sorry.
Your 2 looks like a z. Okay.
Yeah. Sorry. You're...
All right. See, when I was young, that was a 2 and that was a z. So you might notice I always cross my z's. My math teacher was very, very specific on that. You always had to cross your z's. If you wrote that, it was a 2. No matter what you meant, it was always a 2.
Okay.
And if you wrote this, what's that?
Plus.
That's a plus sign. If I want a t, I had to write it like that. And so I still have those habits. If I want a t, I always write t that way. Anyway.
Thanks for the old school lecture.
You're welcome. All right, anyway, back to where we were. Notice what we have now. Right now I have two equations with how many variables? Two equations with two variables. So what we've done is we've reduced, we started with three equations with three variables. We've reduced it to be two equations with two variables. Now we can solve by graphing, we can solve by substitution, we can solve by elimination. The traditional method from here is you solve by elimination. So that's what we're going to do. So we need to make a decision. Do we want to make the y's go away, or do we want to make the z's go away? The y's, okay. It doesn't really matter. To make the y's go away, I think I need to take this one and multiply by 4, and that'll give me a 12y. And take this one down here and multiply it by 3 to get the negative 12y. So I got to multiply both of them. That happens. Not a big deal. Okay, so multiplying by 4 and hopefully not making any more mistakes today. We have 12y minus 8z equals negative 44. And then multiplying this one by 3, that's going to give me negative 12y minus 9z is 27.
So it's a negative 4, you multiply by a positive 4, it's a positive 3, you multiply by positive 3.
The fact that I multiplied by positive 4 and positive 3 is only because one of these was already a positive and one of these was already a negative. When I get done, I want one to be positive, one to be negative, so that when I add them, they cancel out. So sometimes you multiply one of them by positive 4 and one of them by negative 3. But in this case, because one was already positive and one was already negative, we just multiplied by two positives. We didn't need to change the signs. They already had the signs we needed. You always want one positive, one negative. All right, so we add them up. The y's go away. Negative 17z. Oh, we also had to cross our 7s, by the way, too, so that's why my 7s are crossed. I don't know why we had to cross 7s, but that was the rule, so we do. Equals negative 44 plus 27 is negative 17. That works out very well because when I divide by negative 17, z is 1. Z is 1. Almost done, but not quite done. What do I need to do next?
Plug in Z.
I got to plug into z to find y, and then I got to plug in to find x. So we take z, and we plug it into one of these two equations that I circled in red here. It doesn't matter which one. To me, that one looks a little bit easier, so I'm going to use that equation. Truth is, you can use either one. Doesn't matter at all. I'm going to use that one. So that's going to give me 3y minus 2 equals negative 11. Add the two. 3y is negative 9. Y is negative 3. And then finally, I need to find the x. How am I going to find x? Plug those two into one of the originals. Does it matter which one of the three originals? No, not at all. So I'm going to take these two answers. And again, to me, the easiest one looks like the first one. So that's the one I'm going to use. You can use any of the three you like. I like the first one. X minus 3 minus 1 equals negative 1. So x minus 4 equals negative 1. Add the 4. X is 3. Oops. Let's see my original equation there. There it is. So I plugged into the original one, the first one, because I thought it was easiest. So my final answer. Typically, we would write our answer this way. 3, negative 3, 1. I took both of these numbers and plugged both of them in here. So instead of writing y, I wrote negative 3. Instead of writing z, I wrote 1.
So this is like this 3y minus 2. So you're using z and z is 1. So how does z is 9?
Well, I plugged in 1 right here, correct? So when I plugged in 1, I had 3y minus 2 equals negative 11. So then I had to solve that equation. To solve that equation, I added 2 to both sides. Negative 11 plus 2 gave me negative 9. And then I divided by the 3 to get y equals negative 3.
Yeah, I hope there's only like 1.
That's a lot of work.
They're better now.
Probably not.
After doing all
Not that I'm aware of. Unfortunately. I agree, that's a lot of work. No single one step is very hard. And it's really nothing that we haven't done before. But what happens if you make one little mistake like I did and you put a -2 there and you have a 5 instead of a 9? It's going to screw everything up from that point on. And how hard is it to go back and figure out where did I make my mistake? Pretty darn hard, unfortunately. So you need to be very careful on these. One little mistake anywhere bombs the whole problem. How are you going to know you made a mistake and the whole problem bombed? Not necessarily.
Something's not going to, it's going to be a fraction or a decimal.
You're going to get an ugly fraction or an ugly decimal. Can you get fractions? Yeah, you might get fractions on a problem like this. But if I put a problem like this on a test, if you're getting a fraction like 26 over -17, you made a mistake. If you get 1/2, it might be all right. Might be. Generally, when I give this problem on a test, I always make it so that the answers turn out to be real nice numbers. I won't even give you fractions on these. Okay? You should get real nice numbers. But if you're getting an ugly fraction like 26 over -17, you made a mistake somewhere. Try to go back and find it. Not easy to do. All right, let's do one more of these. And then we'll come back tomorrow, or Monday, I guess. We don't have class tomorrow, Saturday. We'll come back tomorrow, Saturday, Monday, one of these days, and we'll try to see what this is good for. All right, so 2x minus 3y plus z equals 2. X minus, you want to use w?
Yes. Use W.
We'll use w. That looks like a sideways 3. All right, we'll use w's here. You're going to confuse me now. X minus 5y plus 5w equals 3. And 3x plus y minus 3w is 5. You know what one of the single most common mistakes is on these problems? You copy them down wrong. That's one of the single most common mistakes. Pretty sure I copied it right, except I used the letter W instead of the letters. Okay, so once again, we pick two equations and we cancel out the x. Which two equations do you want to start with? The first two, I think that's a good choice. What do you need to do to the first two to make the x's go away? Multiply the second by -2. So that's going to be -2x plus 10y minus 10w equals -6, making sure you multiplied by -2 everywhere. First one was 2x minus 3y plus w equals 2. Add them up. The x's go away. I have 7y minus 9w equals -4. Good. All right, so we canceled out the x once. Now what do? Got to do it again. You got to cancel out the x again. So this time I can choose the first equation and the last equation, or I can choose the middle equation in the last equation. Which ones do you like? I like middle and last because I think that's easier. I only got to multiply the middle equation by a number. So what do I multiply the middle equation by? -3. So that's -3x.
Mostly all of them have it to where one of them is no number.
Traditionally, yes, but it doesn't have to happen that way. But most of the problems that will be given to you will be that way just to make them a little bit easier. All right, so I'm multiplying by -3. I get -3x plus 15y minus 15w equals -9. And then the bottom one is 3x plus y minus 3w equals 5. Add them up. What do you get? X's go away. 16y minus 18w equals -4. Okay, that gives us two new equations. And the nice thing about our two new equations is our two new equations only have two variables. Now we need to make a decision. Do we want to cancel out the y's or do we want to cancel out the w's? W's look easier to me. Why do the w's look easier? You take this equation up here and you times it by -2, and that'll give you a positive 18y. That'll cancel with that negative 18y. You could do the y's, but to do the y's, you're going to have to multiply both equations by numbers that would be harder. So I think a clever thing to do is take this equation and multiply by -2. So that's going to give us negative 14y plus 18w equals 8. 16y minus 18w equals -4. 2y equals 4. So y is the number 2. All right, so we're almost done. What's next? Plug it into one of the two ones that I circled in red. One of the two new equations. Does it matter which one? No, not at all. Since it doesn't matter which one, I pick the one that looks easier to me. Does one look easier than the other? That one looks easier because it's got numbers that are a little bit smaller. I agree. That's the one I would use. So I plug into there. That gives me 14 minus 9w equals -4. Subtract 14 on both sides. Minus 9w is minus 18. Divide. W is also the number 2. Okay, that's a happy coincidence. Same number, that's all right. 2 for W and 2 for Y. Now I take both of those answers, and what do I do with them? Plug them into one of the originals. And again, it doesn't matter which one, so you can pick the one that you think looks most simple to you. Which one looks most simple to you? The middle one. I like the middle one. I'm trying to figure out x. I like the one that has the x almost all by itself. So I probably would use the middle. It'll work. X minus, I plug in 2 for y, so that's x minus 10 plus 10 equals 3. That's real easy to solve. X equals 3. So my final answer would be 3, 2, 2. X, Y, W. Which is unusual because we almost always write the letters in alphabetical order. That's why I think they use X, Y, Z. So they can write them in alphabetical order.
I was what asked me y equals 2, and then from the y equals 2.
From y equals 2, you plug into one of the two new equations. We picked that one because it looked easier. I plugged in 2 for y, and then I solved, and I got w as 2. And then I used w and y. You got to use them both into one of the original equations to get x.